Did you guys practice or not? Yes, no, yes, no. If you didn't practice, only God can teach you. I can't teach you. Okay. If you practice, then it's good because then you will start grasping things that basically everything will settle down. Okay. All I'm doing is mostly now plugging up things for you. It's more about you guys trying now, right? And I'll be telling you and explaining you concepts around it. So that's how it's going to be. So yeah, cool. So to start NumPy, why do we need NumPy, right? We need NumPy because we are basically we are still in the data analysis phase right now. Okay, most of these packages that we talk about, which is like pandas that we actually learn, okay, Matplotlib that we'll do, or SciPy, or scikit-learn, or even TensorFlow, and so on and so forth. Most of these APIs are just pretty much using NumPy as a base module, which helps them actually analyze data. It's just a fundamental piece of their structure to play around with any sort of numerical data, right? So now a question would be that why NumPy, right? We already have a lot of functions in Python itself, via which we can play around with this whole data and stuff, right? Um, the answer is Python is slow, okay, in itself. It's not designed to, it was never originally designed to do heavy computations, to be honest, okay. The reason why Python became such a huge thing in the statistical world and data science is because it's easy. It's very humanly readable, right? When you compare it to C, C++, or something like Java, which is very verbose and it is very complex. Um, so what they did, like some smart people, they wrote this NumPy pretty much everything in C because C is the most performant language, right? And they created bindings in NumPy. Okay. Now, how Python calls this NumPy functions and all, Python mostly broadcasts it, okay, and it does not use any sort of loop. So it's like call, get. That's it. There is no loop involved anywhere, and hence why keeping it as performant as they can. So that's the idea behind it. Okay. How do you basically create? So how do you import a NumPy? This is the syntax, right? Import NumPy as NumPy. I have already done it here. And then we can just create an array, something like this here, and just show it. So this is technically a NumPy array. Okay. This is a NumPy array. If we remove all this, then it will be a normal array, but this is a NumPy array. Again, why we are using it? Because it is much more performant, okay? And it actually has a lot more statistical functions, okay, that is used in data science. So those are the reasons why we use NumPy. A lot of the things you will be familiar with when we go through this section, okay, because we have used it, okay. Some parts you might find it new, but a lot of things will be very similar. Okay. Okay then. So, cool. So okay, we have so this is what this is doing. This basically this diagram I imported here, and how I imported it is I can show you actually. This is it's a markdown syntax. Okay, exclamation mark, bracket open, bracket close. square bracket open, square bracket close, braces, and then the image name with extension. If you do this, you should be able to see the image. Okay, it is in our home. In here, I already imported where anatomy.png. Okay, so what does this say? It is showing you three different types of array. Okay, which is one is like first one is one-dimensional array. Okay, or one-dimensional vector, which has a shape saying like, okay, it has only one row and three columns. Okay, so it has a shape 1, 3. Similarly, in the second one, we have a two-dimensional array in which we are saying it has two rows and it has three columns. Okay, it is also referred as an array or a matrix. Okay, so you need to know when someone says vector, it is always one-dimensional array like this with only one row. Okay, as soon as it grows beyond one row, usually people refer it as matrix. Okay, so this is a matrix. I assume most of you have already read matrix in your primary schools and all, so you have at least basic understanding of matrix. Okay, so this is a two-dimensional array, and finally this is a three-dimensional array. Okay, now what does three-dimensional array does? It has one row. Okay, sorry, it has three rows, three columns. Okay, and then again two sort of, because here we are creating only two of them, so two sort of edge. Okay, so we are creating two separate matrices. So that's how three-dimensional array is, and that is why we are saying it has shape of 2, 3, 3. Okay, where 2 is edge or basically number of matrices that we have. Okay, 3 is number of columns we have, and 3 again, the last 3 is like number of, sorry, 3 is number of rows we have, and then last one is number of columns. Okay, it's very simple. Just keep the structure in mind. It might be very useful to you guys when you do something really complex. Okay, obviously I'll share you this image as well, but it's just better to keep in mind this is mostly for your understanding. Okay, to understand it better, let's start creating some arrays. Okay, using Numpy. So I already imported Numpy here, right? If you remember, shift enter, that's how we trigger it. So np array 1, 2, 3. Okay, this is a vector, right? Let's create a2 np.array, and in here let's just create okay, let's create 1, 2, 3.3, something like that, and then let's create 4, 5, 6.5, right? This is a two-dimensional array. Okay. Oh, what did I do wrong? Okay. Yeah, there has to be another brace because it's a two-dimensional array, right? So there has to be another brace, and that works. Right. And then we can create a three-dimensional array. So as such, np.array bracket 1, one-dimensional, bracket 2, two-dimensional, bracket 3, three-dimensional. Okay. Then we say 1, 2, 3. Okay, comma, and then we say 4, 5, 6, comma, enter, okay, and then we say 7, 8, 9, okay, and we close our two-dimensional array. Okay, it's a bit complex, I know. It's a bit complex, but you need to understand why we are using these multiple square brackets, right? First we created one-dimensional, secondly we created two-dimensional, now we are creating three-dimensional. So whenever we create, basically we go one stage above, we need to have everything wrapped inside a square bracket. Okay. In Python, it's everything is possible because it's not strictly typed, right? That's why it's possible. In other languages, it's not possible so easily. It's possible, but it's not possible so easily. 10, 11, 12. Oh, I need to open because again, maybe let me do a better enter here so that it's understandable. Now it is much more understandable, right? So we created one here, there, right? And then everything here is enclosed in there. Then everything that we'll write here, this will be much more readable. Then 13, 14, 15, and 16, 17, 18. Okay. That's there. And then we can basically close it down here, and that's how. Okay. And let's see if it's created and done. It is created. Okay. So now, since we have all these three arrays, there are multiple inbuilt functions that NumPy provides to actually get to get data types and attributes of the NumPy array. Okay. So as such, which ones? Okay. For example, I want to get shape. Okay. A1, A2 dot shape, A3 dot shape, and let's see. 3, 2, 3, 2, 3, 3. Isn't it the same thing that we are getting here? Right? We are basically getting the same thing. And just don't get confused with A1 shape, because that's how by default it represents this one, 1, 3. Okay, because it has just one column. Okay. Okay. That's how you can actually, for example, if you have a very long array or something, and if you want to know the shape, you can use this. Assume you want to know the dimension of it, like what type of dimension it is. So you can do something like A2 endem, sorry, A1 endem, A2 endem, and A3 endem. Okay. So what this is saying is, like, first one is one dimensional, second one is two dimensional, third one is three dimensional, right? We can also get to know data types, for example. Okay, what is the data type of the first one? What is the data type of the second one? And what is the data type of third one, right? Let's see. So first one, we only had integers. If you remember, that's why it is N64. But in the second one, we also mixed it with float, right? and hence why by default everything is float in there. Okay, it's clear. Now whoever had questions. So what basically Python does in here is dynamically it allocates more memory, okay, given what is the highest number of decimal values that we have used. In this case, we have used float 64 or something, so that's what it is allocating by default. Okay. Now I won't explain what is 64 and so on and so forth. You guys can look at it. There are various different types of data types, int 8, int 32, int 64, and so on and so forth. And they all are based on bit size. Okay, their bit size. Okay. Now, what else can you do in here? Let's say if you want to get size, okay, a2 dot size, a3 dot size. Anyone having any questions can just type, okay? 3618. Okay. Now what this means is it has 3 elements, it has 6 elements, it has 18 elements. That's what the size means here. Basically counts number of elements. Okay. Can we get type like this? We were using this, right? Let's see what do we get. We don't. That's why we need to use D type. Okay. We can't get type using type keyword because it's basically everything is wrapped inside a NumPy array. So it just assume everything is a NumPy array. Okay. Can I have a string element in between those integer elements? When you are creating a list, you can. Okay, let's try. I'm not sure. Let's try. Okay, let's try. You can. Okay. What happens if you do this? Okay. What happens if you do this? Let's see. Now it is U21 type. Okay. Which is basically saying it is unsigned in type of like whatever basically stores a string. Okay. So that's what you need to understand. Like I said, list works as it works. In Python, there is no type restrictions. That's why it's Python. It's very easy. Okay. In another type safe language, you will have to explicitly define types, and hence why it is a bit complex. Maybe the only compiled language which comes anywhere near close to easiness and simplicity of Python is Golang, but it is not complete, or let's just say even close to Python's library. Like Python has just way much more extensive library for data science. Okay. Okay. Can we visualize, so can we convert a NumPy array into a data frame, right? So let's try to see. Do we get error or what? So this is how we were doing it, right? Let's convert our matrices stuff, okay? And then okay. It says module pandas does not have any okay. Okay. So A3 doesn't work. Does A2 work? A2 works. Now, the question is, this is what you guys have to answer me. Why does A3 doesn't work, but A2 works? Answer me. Answer me. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's correct. It is because data frames are by default two-dimensional. Okay, that is why. Obvious reasons. Okay, now we saw one way to create NumPy arrays, right? Now there are multiple different ways to create NumPy arrays. So that's just one way that you use like np.array. That's just one way. How can we create NumPy array in different ways? So we can do it by, so there is one concept of once, okay? Which is like you can use once and then you can define a shape actually, and what kind of shape you are expecting, okay? And then you can create it, right? So what I was expecting was once, okay, once with the shape of 2 rows and 3 columns. And hence it by default generated it with default values of 1. And what is the default data type in here when it is generating? Okay, we can see it. Ones dot d type, it's float 64. By default, it generates type float 64 of one's value. Okay, now, okay, once is not ideal. So there are two most common things that you use when you are auto generating arrays. So it's either you are generating 1 by default or you are generating 0. Now, if you're generating 0, it has a very similar way how you can do it. np.zeros. Okay, you have np.zeros, and then same way you need to pass in shape. 2 rows, three columns. Okay, and then you can print zeros. You can also look at type, right? So it printed 0, 0, 0, 0. Again, the default data type is float 64, right? Very simple. What else can you do? Okay, we used ones, we use 0. Okay, we can actually create an array with evenly spaced values. Basically, so we can give a range, and then we can have some sort of spaces in between. Now, let me create it, and then you will know what I mean by that. So let's create a range array. Okay, and we need to arrange it. So we are arranging it, okay, and we are arranging it in this way, okay. Now let's print it, okay. 0, 2, 4, 6, 8. Now we have already done list, so I want someone to type an explanation what this means. Basically 0, 10, 2, and why did we get 0, 2, 4, 6, 8? And the hint is it works exactly the same as we discussed when we were discussing lists. So the first answer itself is very correct. 0 is a start, 10 is a stop, 2 is a step, right? So it starts from 0 and then basically steps. But why doesn't it, why not 10? Why it didn't reach 10? Why it didn't reach 10? Why it is stopped at 8? Exactly. Rule n minus 1, exclusive of last element. I always say inclusive of first one, exclusive of last one, which is n minus 1. Right. Okay. 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 Cool. You guys are becoming super smart by the day. with the speed of light. I'm glad that you guys remember the basics at least, so which is really cool. Okay. What else can we do? So we can also actually pass in some random numbers into there. So NumPy has this random functions, and we can supply random integers 0, 10, and let's just say size is 3 and 5 and random array. Okay. Now, firstly, what is happening here? Anyone has any idea? If yes, type. Or anyways, I'll explain. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, to some extent you guys are correct, and 100% you are correct. It is basically generating random integers, okay, from 0 to 10, and then because we have given it size of 3 and 5, what it did, it generated an array, okay, a two-dimensional array, basically, of three rows and 5 columns. Okay, so it 3 columns, 5 rows, 3 columns, 5. So 3 rows, 5 columns, 3 rows, 5 columns. Okay, and in each of those rows, if you see, it will never exceed the range 0 to 10. Okay, and it randomly pulls those numbers. Okay, so it is selecting those numbers in extreme random. Okay. Now, there are other ways to actually apply the same. This is just one way. For example, we can create random arrays as such as well. You can just do random, okay, and then just pass in shape like this, and then say, okay, like this. Now, what this is doing, okay, what this is doing is it has taken obviously it's a float value. It is basically random array, but so it is called pseudo random. Okay, why it is pseudo random? Because it is taking a default sort of seed around which it generates value. Okay, so it has taken a seed around which it generates some value. So that's what you need to understand. And there is a default sort of seed that it applies, and that's what it is generating. So it's generating float values, of course, but why it is generating only like 0.8, 0.5? So that's the reason, what I just explained. Okay. How else can you generate random array? So you can do this 5, 3, and even this should work. Okay. Right? And it basically generates the same thing. It is just shorthand for random. Okay. And random, like when we type random, we have to add some extra words. With rand, we don't need to do that. So that's what is happening. Okay. Now there is another way, basically, random arrays with seed. So we can give our own seed. So we can say b random dot seed let's say 10. and then random array 4, and we say np random ran end, okay, and we say 10, and then we say size, and then we say 5 3, okay, and wait, what what okay, okay, I did it wrong here, so I did it wrong here, yeah. And we can say, we can try to print. Let's see, what do we get? So we are getting 9. Okay, what if we do it 0? Does it change anything in here? Nothing changes because this is okay. I'm using randint. No, that's why I need to use directly random, right? That we were doing before. Let's just copy this. Okay, let's just copy this. Okay, we can actually do a shorthand, Yeah, we can just do something like this. Seat 7. Okay, and then we can do the same thing that we were doing earlier. And then we can try to, okay, let's just name it 5 because, yeah. And then let's try to print it. Okay. Now, basically what it is doing, whatever random number is generated in here, it is generated based on the seed. That's what is happening in here. Nothing special. Okay. Now it has some seed calculations and all. We don't really need to care about it. We don't give a damn about it. What is happening in here. Period. Okay. Now we created this array, right? A random array 4. What can we do with it? Okay, let's try to update that actually. Okay, what happens if I do this? So now I have this array, right? And what happens if I do this? Oh, I named it. Boom. So what happens is it flattens a multi-dimensional array and removes any duplicates present throughout that array. That's what unique does. Okay. Now, assume we are creating an array, okay, random and int of integer type, range 10, size. For example, let's give it a weird sort of shape. Okay. This. And then we want to show this. And we are saying, okay, firstly, let's print this. This is okay. Am I lagging, guys? Am I lagging? No. Teja, I'm not lagging. I'm not sure why you think I'm lagging. Okay, cool. Okay. Also try to keep your messages much more public instead of like having a direct message. It's just easier so that everyone can help you. Okay. Cool. The jumble of arrays that we created. So it's so complex that I also don't understand. But the idea is, assume you created such sort of shape of array, and now you have this whole shape of 2, 3, 4, 5, and you want to get first four numbers of the innermost array. So how you can do it? So inner 1, okay, inner 2, okay, inner 3, okay, inner 4, and first four numbers. You will have to practice this a lot, okay, but this is how it is. Now, it is not ideal, it is very confusing. You'll have to basically play around with it a lot, okay. It's not voodoo science. I'm just creating some random nonsensical stuff. Try to make you show that there are certain complex things that you can achieve, but you will have to play around with it a lot to digest everything, okay? Or else you won't be able to digest it and it will boom, all out, okay? Okay then. So what we did up until now, we created array and we somehow basically created arrays in so many different ways. Okay. Seed is okay. To understand seed, what is a seed? Mm, let me let me search a word for easier English. Seed, easier English. Mm, okay. So what is okay. So what is seed? So seed is basically, it is a constant sort of number. Okay. It is a constant sort of number that we give to Numpy or any sort of randomization algorithm. Okay. There is a whole algorithm behind it to generate random numbers. Okay. So we give it to randomization algorithm to generate predictable outputs. Okay. If you don't provide the seed, mostly your output would be unpredictable. But when you give a seed, your output becomes much more predictable. That is what a seed does. Okay. Now you have to play around with it yourself to understand a lot more on seed, how it works. Okay. Um, so, right. Right. So you see, like when we are giving any sort of seed, outputs are usually sort of predictable. So it comes within this range. It will come within the seed range always. Okay. So that's what you need to know. Okay. Now assume, so okay, I gave this seed here, NP random seed 2 and generated this, right? Let's try to do this again. Let's try to do this again. Let's try to create this seed thing again. So we did this again. And now let's try to generate this again. And if you see both the times, even though we are generating random values, it is still generating same value. Okay. What this means This means when you are giving a seed, it makes your output predictable. Okay, and you will see the use of seeds in a lot of cryptographic libraries. You will see the use of seed in a lot of cryptographic libraries. Okay. Okay. Clear. Anyone else has any other question? You guys can ask me any question right now. Then I'll move on to manipulating arrays. I explain again. Be specific. Which part, man? I can explain everything or what? Like which part? Okay. So seed is again. Seed is it's not so confusing. It's very simple. There is a randomization algorithm. Okay. This randomization algorithm either generates everything at random, or if you give it a seed, it will take that seed into account and it will always generate a predictable output in a sequence. Okay. It will generate a predictable output in a sequence. Okay. What this means, okay, let's just say in here, we did this. I can do another one here, same. But this is coming from this seed, right? There. Okay. There are two sort of outputs. There are two sort of outputs which are here, right? Now, the next one that I generate, because now I'm refreshing the seed, okay? If I do the same thing again, I should get similar output because I am saying the output becomes predictable. And oh boy, yes, it does. It's exactly generating exactly the same values, right? And this is happening because we have a seed. If we don't have a seed, we won't have this predictable generation of numbers. Now, obviously, you can visualize it, you can see it, but you will only understand the need or value of it when you do some security level cryptography or something, or when you have a specific use case, when you are doing some sort of statistics. Up until that point, you might not really understand why do we need a seed. But for now, you need to understand that, okay, this is what the seed does. Okay. Why do you need it? You will have to wait for a certain use case to come. Sort of. It is similar to random state in algorithms, sort of. Okay. 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 So let me move forward. Okay. Now, it does not have a lot of nuances. Let us just print our A1 again. Okay, we had this A1 here, right? I need to change it. Okay. Because everything became string by default. So this is A1. Okay. Now, let's just say, let's generate a basically blank sort of numpy array again using ones and with same length. Okay. And let's see. Yes, it did. Okay. So if let's just say I want to add this into this, how will it look like? So M A1 plus ones. Okay. Let's see. 2, 3, 4. Works out of the box. Now, this is not so simple This is not so simple when you're using Python lists. Okay. But in here, it works out of the box. Let's just say A1 minus ones. Okay. Works. Let's just say A1 into ones works. I mean, it works because it works because it turned into float. Okay. In here it was integer, and because you are multiplying it with float, it turned into float. A1 slash ones basically divided by ones. Again, turned into float, so it worked. Okay, what do we have in A2? Oh, yeah, we have this. So let's just say A2 and slash A1. Okay. What did it do? So what it did is basically it did a floor division. Okay. It did a floor division and removed the decimals. Okay, rounding off. And sorry, and it divided pretty much everything. So this was like 1 divided by 1 is 1, 2 divided by 2 is 2, 3.3 divided by 3 is somewhat 1 point something something, but it rounded it off, and hence why we are seeing here 1 point. Okay, same like in here it is 4 point divided by 1, it again no change because it is divided by 1. Okay, 5 divided by 2, it will give you 2.5, but it is rounded down, so you will get 2. Okay, 6.5 divided by 3, again it will give you 3.7, or sorry, divided with it will give you 2.7 or something, but again rounded down, so it is 2. So that's how it works. Okay. um what does this do? Okay. A1. Cool. 1 into 1, 1, 2 into 2, 4, and 3 into 3.3, or it's very weird number. Okay. 4 into 1 is 4 again, and so on and so forth. Okay. Now you guys can try all those combinations. Okay. I'll not try. I want to know from you guys though. There's this one question. Okay. Now answer me this. Why are we getting these values in here? Okay. How is it being calculated? Because I know a lot of you guys will be confused. So I want to know why the output is as such. You guys have 1 minute to answer. Hmm. If output is 110 is showing 1, when you load is is a square in Python. No answer. No answer. Some people did answer. Okay. For example, this is correct. It is like 3.3 to the power of 3. So hence it is coming somewhere around 35.937. And then below you see that, right? So it is like um, 2 to the power of 5. That's why we have 25. So, sorry. Um, I'm sorry, 5 to the, because we are doing A2 into A1, right? So it's 5 to the power of 2, 3.3 to the power of 3, 6.5 to the power of 3. Okay. So that's how it is happening. Okay. And that is why we are getting such a large value. Okay. Got it? That's how it is happening. So not a rocket science, not a rocket science, because it is still happening element wise. It is not happening like the full blown. So it's very easy to visualize, okay, what happened in here. Okay. What if so you can also do something like this. So you can just do constant multiplication and it will work. Raising power to 2. It will work. Okay. Or you can do something like np square, and then you can do a1, let's see, 149 works, right? Or you can do np dot add, and then you can say a1 and ones 2 3 4. Even though, I mean, we can do, we were using plus sign as well, and we are using this one as well. It works. Or we can do a1 modulo 2, okay, and we get remainder. Okay. Or we do np dot exponential a1. Okay. And we get this. Now, can someone explain me what is exp in here? Anyone has any ideas? What is exp? Exponent. Exponential. Okay. What does it mean, exponential? Okay. Who has read? Let's try to test. Who has read maths? Enough maths. Okay. How is an exponential basically calculated? How is it calculated though? E to the power of x is right, actually. E to the power of x is very right. And E is, so what is E though? What is the value of E? What is the value of E? Anyone knows it? 2.718, somewhere around that, yes. Okay. So yeah, anyways, nearly 2.7 is right. That's what it is. It's also called Euler's number. Okay. What else can you do? You can basically calculate a log as well. If you want to take a log of everything, you can get log of it. Okay. Um, and if you want, for example, if you want to create massive array, you can create a very massive array very fast. Okay. And it should work. Massive array. Boom. And it is created, right? It is there in memory. Okay. Um, Now, for example, if you want to measure time, so there is this time it function via which you can measure. Okay. And if you want to get sum of this whole massive array of 10,000 elements, okay, let's see how much time it takes. Boom. So it took somewhat around 45 microseconds, 12.9 per loop, 1,000 loops each, and so on and so forth. A lot of descriptions. Okay. Sometimes this time it function might be really useful to you if you are really doing something performance critical. Okay. So it might be really useful to you. How can you give a base value to log? I would suggest that you search for it. Okay. How you would give a base value to log. Okay. It's not very difficult to search. You can search it. Try it out. Make an effort. I can tell you, I know it, but try it. Okay. Uh, so with normal sum, we are taking this much time. And with NumPy sum, how much time do we take? Let's say this. You see the difference? Do you see the difference here? This is Python speed, 455 microsecond, and this is NumPy speed, 2.97. That is like almost 200%, more than 200% performance. More than 200% performance. It's like, boom. Okay. And that is why we have this library. That is why we want to use this library, because it is very performant. And when you are working with very, very large data set, you don't have that much time. You want to save on time. You want to optimize your program. That's why. Okay. Let's just say you want to take out mean of A2, 3.6333. Okay. By the way, the log question I'm just not answering because it's you can do it mathematically. Just search it out. Uh, you can take out mean, you can get max value in that particular matrix. Um, you can also get min value in that matrix. All of it works. Okay. What else? What else? What else? What else? I won't do slicing count. You guys can look for it if you think it's there. I'm just looking for because now I'm at manipulation. Um, there are certain different sort of things that actually you can use. Mode median, exactly. Let's try to understand standard deviation. Okay, very simple. With Numpy, if you want to get the standard deviation, A2, boom, STD, you get basically standard deviation. Okay, the someone just answer on chat. What is a standard deviation? Yeah, man, you can do whole primary class of maths at your own leisure. Anyone has any questions, just type, okay? What is the standard deviation? Answer. I mean, in simple terms, you guys keep on asking me, sir, don't use hard English. So in simple language. How much the values in a data set are spread around the measure of central tendency. That is actually very good answer, to be honest. Okay. So it's mostly exactly how spread out the numbers are in a set or data. Okay. It tells you exactly the same thing, how much it varies from the central point or from your mean of your data set. Okay. Um, what does it say when something has a low standard deviation? It means that the spread that you have, mostly the data is somewhere around your mean. Okay. uh, and if standard deviation is high, that means it is basically nowhere near around your mean. That's what it means. Okay. So that's what the standard deviation is. And when doing some really high level ML sort of thing, you don't really need to learn everything. This is where like Google and everything comes into picture. But you need to understand, okay, this is what it means, and this is sometimes you need it. Sometimes in some project it's necessary. Okay. So that's where it comes into picture. Okay. Um, okay. Let's try to and what okay, what is the formula? Basically the formula, okay. This is so np.var actually calculates variance. Okay. This calculates variance. And formula is np.square root of variance. Then you get sort of standard deviation. Okay. Okay. We have seen mean, we have seen standard deviation, we have seen variance. Cool. What else? Reshape. Oh, we are not doing mathematical PhD. Huh. Quartile deviation. Okay. Let's try to create a sample in here. Let's try to, okay, let me get a snippet. Okay. So what we are doing, we have created two arrays with high variance and low variance. Okay, we have created two arrays with high variance and low variance. Let's try to get it all. Okay. Obviously, it does not print everything, so it's okay. So, okay, we have this. Now, we want to plot something out of it. So you remember we had this amazing library called as Matplotlib, and then it has this function which we can use to plot graphs. And then what we'll do is we'll plot a histogram. That's what we said. Hist means histogram, right? In our previous class. And we want to see how does high variance array look like. And then we can plot and see, and it looks like this. Boom. And we can see amazing plot. Okay. Or we can do something like list lower array, and we can say plt dot show. And okay. Now, what's the difference between this one and this one? Just because it is Jupyter, okay? Just telling you, just because it is Jupyter, it is showing you the graph here with hist. But when you are actually working directly on your terminal or something, you do sometimes, okay? Then you will have to use this show, okay? So that is why it does not show all this array and stuff in here. And you can see this histogram. Anyone who is raising constantly their hands, just type out your question. Okay. Okay, no question. Cool. Ooh. And what else do we have? What else do we have? We have something called as reshape, actually. Numpy reshape and transpose. Okay. I had a good resource actually for reshape and transpose, and I'm not able to see it now. Okay. No worries. We will see it here ourselves. What does it mean? So reshape. Okay. Let's just say a2 dot reshape, and we are doing 2, 3, 1. Okay. And then we are trying to print a2 reshape. Okay. Can anyone explain me what just happened? No one? No one understood what happened? I mean, rows into columns, yes. But basically what we did is we changed the original shape of A2 into this new shape 2, 3, 1. Right? We correct. We changed it into 2, 3, 1 sort of shape. 2 matrix, 3 rows, 1 column. Or 2 dimension, 3 rows, 1 column, 2 edge, 3 rows, 1 column. However, you can remember it. Okay. That's what happened. Okay. Just because we want to play around with it a lot, so we'll just multiply it with A3 and boom. Now we see something meaningful. Okay, so we multiplied it with A3, which was already three-dimensional, and hence we multiplied it with it. Okay. What happens if I do A2.T? Okay. What did change? Cool. Transpose. But what changed? But what changed? But what changed? What changed? Okay. Exactly. Rows becomes columns. So if you remember, we were having rows like this, sorry, columns like this, 1, 2, 3. Okay. But now we have 1 and 4. Okay. Instead, we have 1, 2, and 3 down the line. So basically change the shape. Rows becomes columns, columns become rows. That's what transpose and reshape does. Okay. I'm not sure if you'll require all of this. Maybe you might not use this a lot, but at times it is required. Okay. So just good to remember it. That's the whole point. Okay. 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 Or not. Okay. Uh, okay. So we see A2 3 shape like this, right? We have this product here, right? And assume we are multiplying. Let's do something like this. Mat 1 1 equals A2 dot transpose. Okay, but before this, let's see, NP dot A2 transpose into A3. Oh, sorry, comma A3. Okay. No. I need to do it like properly. Okay, let's do it from scratch itself. Then only it will be understandable. Okay. Let's create matrix 1 with np dot random dot randint and 10 range and size is let's just say size is 5 and 3, and then something like this, and then we create mat2, and then same thing, random dot randint, and then 10 range, and then size equals 5 3. Okay, that's how we create it. And then um, mat 1 dot shape comma mat 2 dot shape. Okay, we created it, right? Mat 1 into mat 2, what do we get? We get something like this. Okay, they are perfectly of the same shape. Do remember this. Now, if something is of really same shape, what we can do, we can also use dot operator. Okay, so what we'll do, mat 3 equals np dot mat 1 and mat 2 dot, but let's transpose it. Okay, and mat 3. What am I doing wrong? Mat 2. Comma. Okay, comma. Yeah. And so what is the difference in here? What do you think? Okay. Maybe you might think, okay, maybe because of this transpose it's happening, but no. Okay. So shapes 5 3 5 3 not aligned. It says, okay, what's happening here? Dot product. Yes, dot product. But what is different about dot product? Yes, but okay, how is it different than your multiplication star? Exactly. It has to be MXN and NXM 100% because that is how dot products are calculated. Okay. And in dot products, actually, you multiply rows of one matrix to column of one matrix, right? That is how dot products are calculated. Cool. While when we are using this direct element wise multiplication, we are doing like one-to-one mapping on multiplication. But dot product does not work like that. It is different. Okay. They correct. Very correct. Okay. So that's what our dot product is. Now, no. Um, I think we have pretty much covered. Yeah, we have pretty much covered NumPy. There are only few things that's left. Uh, so comparison, we already know. That's how we do it. Like there's no difference how we do comparisons. Um, Give me 1 minute. Okay, sorry. Indexing. Let's play with plots. That's what you guys need to do. I'll run through plots. So I am thinking like this. Okay. Um, we don't have a lot of things that I need to cover in Matplotlib, to be honest. Um, to be honest, I just want to start with scikit-learn because Matplotlib has mostly like you play around with the axis and so on and so forth. So it's a lot of command that you need to remember, uh, which I can run through, but I don't want to spend a lot of time in there. Okay. So, okay. Pretty much I covered all of this thing and there are some other things like argmin, argmax, and so on and so forth. Yeah, we can look at it quickly. Like, for example, np dot argmin a1, np dot argmax a2. So something like this, or I'll just say a1 to understand, which is basically getting min and max. Okay. You can also do it with like three-dimensional arrays. Basically, let's say A2 and axis equals 0. So 1, 1, 1, right? So based on axis, you can play around it. It compares elements in a column. So when you are doing axis 0, and then when you are doing axis 1 in here, it will do it with rows. Yeah, it does it with rows. So basically, yeah, everything is done. Everything is done on NumPy. And now let's play plot. Okay. Okay. Let's play plot. So, Matplotlib is basically built on top of NumPy itself. Okay. Matplotlib is pretty much built on top of Matplotlib. As simple as that. Okay. And Matplotlib has two sort of different interfaces. Okay. One is PyPlot API, which is sort of less flexible. Okay. And there is an object-oriented API. Okay. Which is not so flexible. Which is very flexible, and ideally for complex situation, that is the thing that is recommended. We have already imported Matplotlib, so I'll go beyond it. Okay. Let's quickly look at some easy examples to visualize, right? Okay. For example, let's prepare data. I'll just run through this because this is very easy and a lot of things will come from, for you guys from practice only. Okay. I can visualize it, I can tell you, but it is a lot of this is just commands. Okay. So we are using these two arrays. Okay. And if you want to plot, okay, if you want to plot, you can say something like, okay, okay, let's do the easy one first. So PLT plot, and then we are doing X and Y. So this is easy plot. Loyal plot. Easy plot. X, Y. Right. X, sorry, you see X here, X-axis, and then Y-axis. X-axis, Y-axis. X-axis, Y-axis. X was what? 1, 2, 3, 4. 1, 2, 3, 4. Okay, Y was what? 11, 22, 33. That's it. Okay, that is what is happening. Let's try to do it in a much more structured way. So we are saying, okay, figure size is of 10, 10, and then we are creating a subplot. Okay, and we get two variables, figures and axis, and we need to basically, so what figure size here means, we are passing a width and a height of this plot that we want to have. Okay, now we are going to use AX, okay, axis to plot. Okay, so we can do something like X plot X, X and Y. Okay, and see. So now we can customize it in a much advanced way. Okay, yes, you can plot X, Y, Z simultaneously. You can experiment with it a lot. So, okay, for now, just understand what we are doing. Okay, so X, what it does, it basically adds some access. Okay, this is basically object-oriented interface. Now, if you see, when we were just doing plot, it was just like directly plotting it for us. But when we are using this subplots and using this object-oriented interface, we are much more flexible. And that is why it is also recommended, because we can do a lot of things now. Okay. For example, if you want to set title and label, okay, if you want to set title and label, uh, we can do something like this. And let's see. So we have a title simple plot, right? And then we have this is my y-axis, this is my x-axis, right? Um, Let me decrease the size, man. This is too much for this screen. Uh, okay, yeah. This is my y-axis, this is my x-axis, this is a simple plot. So you see a lot of details in here, right? If you even want to assume you want to save this image, okay? If you want to save this image, you can save it using something like figure dot save. They both are different libraries. That's the difference. Seaborn and Matplotlib. Okay. Okay. Save fig, and then you can just save it. I won't save it. Don't have, but you can try. Okay. You can just save it. It saves. PNG. So it will save it in an image format or something when you use this save fig. Fig.save fig. Save. Okay. So ideally, you won't see outright results of Matplotlib in a very short way, okay, in a very short time. But slowly and gradually, you will try to, you will basically understand the advantages of it. Explain Fig and X. There is nothing very complex to explain here. Like I said, there are two types of interfaces Matplotlib provides. One is PyPlot, which basically does not allow you any sort of customization. It just plots and that's it. You are to get used to it. Then there is object-oriented interface, which is what we are using by using this subplots function, right? And it gives us two variables, which is AX and Fig. Now they have a lot of sub functions that we can use to customize our graph. For example, setting up labels and so on and so forth. With figure is the one where like figures are generated and we can save that figure. So that's what I'm doing. So nothing much to explain. There's no logic here. Okay. Okay. Um, what else? What else? Hmm. What else? What else? There is one more image that I want to show you guys. It sort of explains, so just like how I explain anatomy of NumPy, it explains anatomy of Matplotlib. So let me try to get it for you guys. Okay. Anatomy. My screen is visible, guys. Yes, no. Yes. Okay. Cool. So this is how the anatomy of basically Matplotlib is. You don't need to care about what is written here, but what you need to care about is what is here. Okay. So what each of these parts are called. This is x-axis, we know. This is y-axis, we know. This is where x-axis label will be represented. This will be y-axis label. Figure is this whole figure, okay? So that is why it's called anatomy of a figure, okay? These are ticks. These are ticks. And then there are major tick label. So when you see some numbers or something, they are major tick labels. Okay. And then again, this is major tick label. This is minor tick label. So what is like at the bottom, the smaller label on the x-axis you see is minor tick label. Okay. The bolded 0, 1, 2, 3, 4 on x-axis you see is major tick level. Okay. This is major tick level. Okay. Um, these are line plots and so on and so forth. So basically everything inside it is a plot. It can, and then there it's divided into grids. That's how it is there. So this is what the anatomy of a figure is. This is how usually you understand, okay, how something will be divided. Okay. Nothing complex in Matplotlib. It's very simple, very easy, just looking like a wow. So elegant, so beautiful, just looking like a wow. Okay. But cool, cool. So we are here, we plotted. Okay. Now there are different types of graph that we can actually do. Let me, okay, right. So there are different types of graphs that we can do. For example, if I want to create, so a line space, okay. And to understand what is a line space, this is a line space. Okay. You can look about it, like what it does, line space. Okay. But for your understanding as of now, you just need to know it generates an array. Okay. Now we already saw this PLT, big X, subplot, right? And then we will plot something beautiful. And then what we'll plot is we'll use X on X-axis and we'll use exponent. Basically, we'll use square root of X on Y-axis. And then, okay, why do I write ploy always? It's plot. And then we'll plot and it looks something like this. Zoom. So what it is telling us? Okay, how do you look at a graph? This x-axis was at 0, then it grew and then it grew, and because the value on y-axis is growing. Value on y-axis is growing exponentially. Okay, this is basically this graph means exponential growth. If by far, I don't know how much data structures algorithm you have done, but if you remember time complexity and square, they try to visualize and show you a similar graph of n square. Okay. What if I want to create a different one? So we can just clean up what we just created. And maybe I don't want to create this line graph. I want to create a scatter graph. Okay. So I can do scatter and I can say NP, EXP, X, and then something like this, and boom. And then we see we have so much of scattered. Now this is an exponential growth. Okay. Zoom, 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 zoom. Okay. What if I want to make something out of a dictionary? Okay. So assume we have a dictionary like this. We have different sort of butter prices. So almond butter costs like 10 rupees or $10 or 10 euros, whatever currency you like. And peanut butter costs 8, cashew butter costs 12, so on and so forth, right? And again, our like fixed subplot. Okay, we want to plot it. And then if I want to plot it, so let's try to use keys for for a bar graph. Let's try to use keys and values, and let's try to see. So boom, we got a bar graph, and what we are doing, we are using keys as labels here, right? Almond butter, peanut butter, cashew butter. That's what we are using keys for. And we are using values for your values for the bar graph. That is what is happening. Okay. If you want to customize it, like I said, you can customize it. Okay. You can customize it. And then you can plot it again. Okay. Whoever asked me for attendance can go to hell. Okay. No pun intended. So we can have a title and then we can have a Y label and basically saying a price and so and so on. Okay. I don't take attendance. Whoever takes attendance, message him. Okay. Cool. So we drew a scatter graph, you drew a bar graph. We already did histogram a lot of times now. So we have scatter, we have bar, we have histogram, we drew from what? We drew from okay. What you can do, you can also create multiple subplots. Okay, you can also create multiple subplots. Like for example, here you see AX1, AX2, AX3, AX4. We are creating so much of multiple subplots, and then we are saying we have 2 rows, 2 columns, and then we have figure size of 10 and 5 and so on and so forth, right? Let's also create this X actually. Okay, let's create an X. Let's create X. So we are creating a random array of having which has basically 1,000 elements or something. Okay. And then we can do similar thing, but for each for different axes. Okay. Yeah, looks so beautiful. Just see that. Voila. Habibi. It's amazing, right? So you can see a plot, straight plot, scatter plot, basically your bar graph, and then you can see your histogram, everything, and so on and so. And we are operating on different axes, if you see, right? So it is quite amazing that you can do with it. So you can do a lot with it. Okay. You can make it even much more advanced. Okay. You can create multiple subplots as such as well. Okay. For example, 2 rows, 2 columns. That's what you're saying. 2 rows, 2 columns. Figure size is 10:5. And then you want to see like, okay, x is 0, 0, 0, 1. So you are also defining on what metrics basically, which graph would be there. Okay, there. So we said line graph on 0, 0. Yes, it's there. Scatter graph on 0, 1, 0, 1. Scatter. Yes, it's there. Bar graph 1, 0. Yes, it's there. Right. Nice. What else can we do? What else can we do? Okay. I don't know what's attendance. Someone else in from Blackbucks can give you. Okay. The last thing, man, there is so much left in Matplotlib that I want to show you guys. Not so much, but it will take at least half an hour more, for which we don't have time because I want to mix up pandas and then show you guys. But okay, so we'll stop here. We'll stop here. We'll do this pandas thing tomorrow. Okay. Yeah, because I don't want to stop when we do pandas stuff, and then we'll start scikit-learn tomorrow. I think we have covered a lot today. We completed NumPy completely, at least the parts that I wanted to cover. To a lot of extent, I also showed you how and you can use Matplotlib. Okay. I am sharing you my notebooks. I'll give you a major assignment soon enough. Okay. Once we are done with all these three major libraries, which are like NumPy, Matplotlib, and Pandas, I'll give you one assignment that you need to complete mixing all of these three things. And then we'll well into scikit-learn. And that is a very big module that we will go through. Okay, if you guys have any questions, you can ask me. I don't know, Ajay, if you can get attendance or not. That's not in my discretion. Okay. Good night, everyone. Whoever wants to sleep, if anyone has any questions, just ask me. I'll be here 3 more minutes and then I'll drop if you don't have any questions. Okay. And do practice everything that we are doing here, because again, this does not involve a lot of logic. It is a scripting. Without any practice, you will not understand anything. Okay. All I can do is like help you around things. When will you give the assignment? I'll give this week. This week, basically tomorrow, I'll give you an assignment. What is today's topic about? In Hindi, we say that रावण मर गया but पूछ रहे हैं राम कौन है. Means Ravan died and you are asking who is Ram. Did you know about employability test? I don't know. For me, anyone who is actually good enough in problem solving is employable. I hire at least 200 to 300 interns pretty much every year for different companies. So, and I have hired at least 10, 20 people full time, senior level. So it completely depends on your skill. I would say good thing would be you start creating your GitHub presence, start committing to GitHub, creating projects, mini projects. That will help you a lot in becoming much more employable. Coding questions can be hard, it's subject to market risk. No online compilers to practice and teach you Jupyter. The only thing that you need to learn Jupyter is some common sense and recursive practice. Why common sense, I say? Because when you open Jupyter, when you open file or anything or something like that, even their documentation, they have written shortcuts. Okay. So you can use shortcuts, and I don't know if you can use Google Colab or not. If you can, feel free to use it, but not with me. Okay, guys, I don't think so. You guys have any questions? So I will drop. I hope you guys are understanding. I know it's a bit boring to see no logic and everything like syntax, but maybe you'll enjoy it more when we start doing scikit-learn. So yeah, looking forward to that. You lost your attention last 4 sessions. Okay. I don't know how to bring your attention back, but I can try. Okay. So for now, it's more sort of scripting, just like I said. So it's natural. But the thing is, you need to practice. Next topic is we will complete Matplotlib and then we'll start scikit-learn. Okay. I also want you guys to actually code along with me if it is possible. Try to have some sort of editor side by side on which you can code. Okay. It will help to you guys itself because you will code and you will see what is happening. Otherwise, this whole thing will be boring. Sir, I lost my attendance last 4 session. If you didn't come and then you lost attention, again, I can't help, right? You have to be present. Probably with scikit-learn, you will start anew. So to some extent, we'll cover some things that you don't need previous knowledge on. Okay. Before sessions topic. There's no before session topic for now. Okay. So next session is tomorrow. What is your questions? I don't see your questions. GHG. Itachi. Okay, you're asking to Itachi. Cool. Okay, guys. Bye. I'm dropping. See you guys. Good night. Have a nice night. Sweet dreams. And enjoy. Okay.